Okay, so today we're doing everything there is to know about rectangles. All right, so the first thing we need to know is that a rectangle is what type of a shape?
Parallelogram.
Yes, everybody should know it's a parallelogram. So what does that mean? That means that everything that applies to a parallelogram also applies to a what?
Rectangle.
Also applies to a rectangle. So what can you tell me about the diagonals of a rectangle? They bisect each other. That's right. The opposite sides are what?
Equal.
They're congruent. All right. Now look, I'm trying to get some things done. I'm looking up. Some of you guys are having your own little conversations. All right. Stop. Pay attention. I don't want to. I can stop right now and just have you do it on your own. All right. I'd like to get through. It's very simple. Very simple again. All right. I'm trying to get you to look at a parallel or at a rectangle as a parallelogram, and then say that everything that applies to a parallelogram applies to a rectangle. And then there's some other special conditions that we're going to talk about. So I want to draw first a rectangle, and what we're going to do is you're going to tell me some facts. All right, this is everything you should know. All right, and I said earlier, everything that applies to a parallelogram applies to a rectangle. So in this case, we know that the opposite sides are congruent. We definitely know that. Now, in this case, because it's a rectangle, what makes it a rectangle, though? What differentiates a rectangle from a parallelogram?
The two sides are longer than the other two sides, right?
That is true, but yes, that's the most important thing. All right, that every rectangle, the angles are 9 degrees. So what's true now about all of the angles of a rectangle? They are congruent, they are equal, they are 90 degrees, however you want to say it. All right. Now, because you know that, all right, you should be able to now tell me something about this or the diagonal here and the diagonal here. So first of all, what's true about the diagonals of a parallelogram? They do what to each other? They bisect each other. Now, in a parallelogram, are the diagonals congruent? No, we said, remember, if it tilts, one diagonal is getting smaller and one is getting larger. All right? But in a rectangle, what looks to be true about the diagonals? They look congruent. All right? They look congruent. Now, how easy is that to prove? All right, it's super easy to prove because, now just watch, so we don't have to do it so much later. This angle right here is how many degrees? 90. This and this. All right, so what I'm doing is I'm highlighting the top rectangle. All right, I'm trying to get you to look just at the top rectangle. All right, and then what I want to do is I want to look at the bottom rectangle. And if I was asking you to prove that diagonals are congruent, you could easily say the diagonals are congruent because of what?
Side angle side.
Yes, we would first say that the triangles are congruent by side angle side, and then you would say that the diagonals are congruent by, yes, by CP/CTC. Now I'm trying to tell you, all right, there's no way to remember all the rules. All right, does everybody understand that? All right, I mean, some of you are going to, which is perfectly fine. But the majority of us will not sit down and memorize all 30 rules that there are in this chapter. In my opinion, the easiest way to do it is just look at it and say, hey, obviously those are what? Those are congruent. All right, that's what I'm hoping you can do. All right, as soon as someone tells you it's a rectangle, you should be able to say the diagonals are going to be congruent by corresponding parts. Because the top triangle and the bottom triangle are congruent by side angle side. Those are the things I'm trying to tell you. All right? So, now, when we look at the diagonals. So I'm going to look up there. Make sure you're seeing what I'm saying. Do the diagonals bisect the right angle?
No. No.
Now, for those of you guys who are not sure, you're not demonstrating what I'm asking you to do. All right? So let's assume that they were equal. That would mean that this angle right here has to equal that angle right there. That's what you're telling me. All right? But if you look at it more carefully, this angle right here, this angle right here is equal to this angle right here. Does everybody agree with that? And then if I showed you this angle right here, that would be equal to what? That angle right there. And then those two angles added together are what? 90. But are those angles equal?
No.
No, because you told me about the top triangle is equal to the bottom triangle. But if you'll notice, again, I'll try to demonstrate. This triangle right here, the corresponding angles don't match up. All right, and what do I mean by that? This angle right here does not correspond to this angle right there. Everybody see that now? Now again, those are just one of the rules that they're always going to ask you about. All right? The diagonals of a rectangle do not bisect the angle. And some of the kids, one of the reasons why I'm bringing this up is because that's one of the biggest mistakes kids make, is they think that because the diagonals are congruent, the angle is bisected. And that is not true. Does everybody see that? All right? It's really simple to prove everything that I've stated. All right? It's really simple. All right? And that's why I say it's not really that important. If you can draw it yourself, write down the facts that you know about a parallelogram, and then when you make the triangles or when you draw the diagonals, you can see the rectangles are either congruent and what parts are congruent. And I just think that's the easiest way to look at it. All right? Because again, we have to do trapezoids, we have to do rhombus, we have to do a square. There's all these different shapes that you have to remember all the different rules for. All right? And it's hard. All right? That's why I'm showing you visually. You should do it visually. All right? Not try to memorize all the rules. All right? And as we proceed down the page, you can see now how easy it is. All right? So let's get started. I think I said everything I needed to say. All right? So again, it looks like we have to do 1 through 31. So let's get started and make sure we're good. All right? An X brace on a rectangular barn door is both decorative and functional. It helps to prevent the door from warping over time. If ST, all right? So if this right here, if ST is 3 3/16, then what is TQ? 3 3/16. Okay, I'm happy with you on that.
I did the decimal like you said.
No, just write it as the fraction. We're not rounding fractions. All right? Not rounding. All right? Now, it also said PS is 7. So we'll go ahead and mark that. PS is 7. And then angle PTQ is 67 degrees. So PTQ is 67 degrees. You should be able to find out all of the other angles now. All right? Now, what is true? Somebody tell me what's true about PT, ST, TR, and TQ. They're all what? They're all congruent. All right? So what I need you to do is, I need you to see that, those are all congruent. All right? And if those are congruent, then what's true about those angles here and here? They are congruent. Everybody good with that? All right. And then what's true about these angles here? And then, of course, these are congruent over here. And, of course, the other is true with this angle here and this angle there. All right, I think that's pretty obvious. All right. Now, how do I find, let me try to blow this up a little bit more. How do I find these two angles right here? What are those two angles? How do I figure it out? Tell me.
Do 180 minus 67 and divide by 2.
That's all it is. All right, those angles, 180 minus 67 divided by 2. Everybody agree with that?
Yeah.
Somebody tell me what that is. What did you say? Thank you, 56.5 degrees. All right. Now the question is, how do I find these angles right here? How do I do that? Tell me.
180. So 123. No, 113 divided by. 113 minus. Divided by 2. No.
Think about it. Tell them the quickest way.
180 minus 113 minus 2.
Someone tell them a really super easy way. 90 minus 56.5. Everybody see that? 90 minus, you're correct, what you said. But you see what I'm saying? These are right angles down here.
Okay.
Right, so the absolute easy way, right? And I know what you were trying to do. All right, so you did 180 minus 67 to get this angle right here. And then what we did was we did 180 minus that again, right, which would take us back to 67, and then take 67 and divide it by 2, right? Or we could have just said 56.5 subtracted from 90. All right, everybody good with that? Very simple. All right, so we now have figured out all of the interior angles, correct? Very simple. All right, now, so let's look at this right here. So somebody tell me what QR would have been.
7.
7. So let's go ahead and knock this out. What's SQ? I like that. Well, remember, SQ is the whole length, right? So 3 and 13/16 times 2, which would be 7 and, did you say 5/8? Is that what I said?
Yeah.
7 and 5/8. And what did we say TQR is?
Yeah.
Wait a minute.
No,
TQ.
113.
Whoa. Say it again. I think it's 33.5. Now again, guys, listen, again, I really don't mind wrong answers, right, at all. That's what I want you to do. Speak up, whatever you think is the answer. All right, we're trying to speak freely. And then when you don't know something, now's the time you speak up. Say, hey, well, how did you get that? Or is there an easier way? All right? What?
How did you get there?
Well, because remember, this right here was, this angle right here is 56.5. So all of this, what I'm going to do now is, I'm going to erase this real quick, get it out of the way. Right? So this angle right here is 56.5. Agreed? So that's the same as that angle, and that angle, and that angle. And then the other 4 angles are 90 minus that. Are we good with that now? Anybody have any questions? And 90 minus 56.5, what do we say it was? 33.5. Correct now? All right? Everybody good? All right, and then finally, TSR. Yes, 56.5. I'm good with that. All right, now let's take a look at number 5. FD. So here we go. FD is the long diagonal. EG is the other diagonal. So what's true about those diagonals? They're equal. So we have 3x minus 7 equals x plus 5. Do our mental math there, and we just have x equals what? I think x equals 6. All right, now again, that's part of the reason why some of you are going to be disappointed in your test grade. Because you solve for what? X. It's not asking for X, right? What is it asking for?
EG.
EG. So EG would be what?
11.
I think EG would equal 11. All right, I'm trying to give you a heads up, man. I hope you're listening to me, because on the test, if you solve for X, one of the multiple choice answers is going to be that. All right? Anybody have any issues? All right, now here we go. So EFD. So EFD is this angle right here, correct? And DFG is this angle right here, right? Because it's a rectangle, they add up to what?
90.
So we would say 3x what? 3x plus 9 equals 90. I personally think dividing by 3 is easier. X plus 3 equals 30. So x equals what? Yes, x was equal to 27. And now I'm looking back and trying to figure out what angle they're asking me to do. EFD. So EFD. So that would be what? Yes, I think you're correct. 51 degrees. Any issues with that? All right, so now let's set up the proof. All right, let's see how good we are. All right. Copy. Statements. Reasons. All right, let's take a look at this and see how we're doing. Don't know why it's doing that. All right, here we go. Now, the first thing it says is that it's a rectangle and BC is equal to, yeah, so I'm going to go ahead and try to write that. Let's see if I can paste that. All right. Now, my recommendation is when they tell you something is a rectangle, all right, then I'm looking at it going, this is congruent to this, right? For sure. And because it's a right triangle, I'm going to go ahead and mark this is a 90-degree angle. And I'm trying to prove that AC is congruent to, wow. So I think we just by marking those, I think it's done pretty much. All right, I think it's done. Now, again, don't, you know, you're supposed to help yourself out by not just writing down what I'm telling you. All right, you're supposed to understand what I'm saying about it. I just pretty much proved it. All right, my only mistake right here would be this should be a second line. All right. What?
What would the reason be for like AB is congruent to ED and AB is congruent to ED?
It's the definition of a what?
Rectangle?
Definition of a rectangle. All right. Or definition of a parallelogram.
Act by opposite sides of the parallelogram.
That's what I prefer, honestly. That's what I prefer. I just like to say, hey, why? Because opposite sides of a parallelogram are congruent, or opposite sides of a rectangle are congruent. All right. That way you don't have to remember if it's a definition, if it's a theorem, if it's a postulate. Just write out what it is. That way I know you know what it is. All right. So I like what he said. So he said that AB, oh, by the way, I forgot to put given up here. So we said AB was congruent to ED. And I like that. Opposite sides of a rectangle are congruent. All right. Now, what do we know? Somebody, what else can you tell me? Tell me.
Angle B is congruent to angle D.
All right, so let's go ahead and write that. Angle B is congruent to angle D. Why is that?
All angles in a rectangle are congruent.
I would accept that. You could also say
I
what?
was going to say all right angles.
I would probably say all right angles are congruent. Right. All right angles are congruent, but do I really care? I don't care. All right. The fact that you know it's a right angle, right? That's because it's a rectangle. All right. So now what? What?
I think I could say that line AC is congruent to line BC
That is correct, but
because of CPC.
yes, but we haven't said the triangle's congruent first. We have to say the triangle's congruent first. So what am I saying? Triangle what? Triangle ABC is congruent to what triangle? Good job. Triangle EDC. And why is that? Nope. Tell them.
Side angle side.
Side angle side. Remember, the triangles are congruent. Side angle side, side side side, angle side angle, angle angle side, hypotenuse leg. Those are your choices. All right. But in this case, we could just say what? Side angle side. Now, Emily, we could say, yes, that's easy for you to say. AC is congruent to EC, and that is your CPCTC. All right, guys, I really just do not think that's that hard. I really don't think that's that hard. All right, everybody should be able to look at that figure, look at that shape, know what you know about rectangles, and be able to conclude that AC has to be equal to EC. All right, let's see if there's anything more difficult or more challenging. Graph each quadrilateral given with the given vertices, determine whether the figure is a rectangle. All right, so if I want to use the slopes, all right, I don't care about graphing, all right? But what is true about the slopes of the consecutive sides of a rectangle? What would they be? No, they would be. So what does that tell me about the slopes? There, say it again.
Negative reciprocal.
Yes, the negative reciprocals. Is everybody with me on that? They would be negative reciprocals. All right. Now, again, all right, we're going to use the slope formula here to determine if it's a rectangle. All right, so if it's a rectangle, that means that all of the slopes of the consecutive sides would be negative reciprocals. All right, let me see if I can give you an example. All right, and what I'll do is I'm just going to make a rectangle this way. All right, and partly why I want to make it this way because it doesn't have to be vertical or horizontal. All right, so let's try to just plot these points out. If I plot negative 4, 3 over here, and then 1, 5, we could say is over here, and then 3, 1 over here, and then negative 2 over here. All right, now, again, it would be easier, obviously, with graph paper, but mentally, all right, visualizing things, I think we're good. So I want someone to tell me what the slope of that line is. What is it? Well, we wouldn't say double negative. Does everybody agree it's 2 over 5? Right? Now, let's just say you're not 100% sure, right? It's change in y, right? So I went from 3 to 5, which is what? 2. And then I went from negative 4 to 1, which is what? 5. Right? So that must mean the other slope has to be what? Negative 5 over 2. So let's see if that's correct. All right? So the y's, I went from 5 to what? 5 to 1, which is what? 4. Is that right? I went negative, right? And then I went from 5 to 1 is negative 4. And then from 1 to 3 is what? I'm okay with that. Right? From 3 to negative 2 is 5. Right? I went negative 5 and then to the right 2. So that looks good, doesn't it?
Oh, wait, it's not.
Yeah, that's what we're saying, guys. Come on, you guys are supposed to help me out. It says, determine whether the figure is a rectangle.
No.
And we would say what?
No.
No, it's not. Close. All right, but definitely not. All right, because I think this one would have been what? 3 over 5. All right? Anybody have any questions with that? Again, guys, you know, if you're still unsure, remember y2 minus y1 over x2 minus x1. Now, determine whether the figure is a rectangle by using the distance formula. All right, so does someone want to tell me about how I would prove that it is a rectangle using the distance formula? Tell me, good. I'm not asking you for the distance formula. I'm asking you if I want to prove using the distance formula, what would I be proving is true to say that it's a rectangle? Now, before you say you don't know, we talked earlier about what in specific? Earlier, what was the... What differentiates a rectangle from a parallelogram? Now, you should say, well, the angles have to be 90 degrees. But I'm not talking about an angle. I'm talking about a what? A distance. So come on now. Look at the rectangle and tell me what I could prove. What could I say is true to show you that it is a rectangle? Tell me. No. Because why? Because I'm not asking about angles. I'm asking about a distance formula. What distances must be equal? Try.
The opposite sides.
Well, if I prove the opposite sides are congruent, that is true, but the rectangle could be a what? Parallelogram. Good. What do you think, Miss Fridella? Well, I thought you were raising your hand. So tell me about it. What distance? Tell them.
Diagonal.
Yes, guys, I've just been talking about the diagonals. What's true about the diagonals of a rectangle? They are equal. So if you can show me that the diagonals are congruent, then it must be a what? Must be a rectangle. So the distance formula, all right? Again, all right? The distance formula was
x2 minus x1 squared plus y2 minus y1 squared divided.
Nope. Square root. Thank you. Good job. Square root of that. All right. So those of you guys who weren't sure, all right, let's go. D equals x2 minus x1 squared plus y2 minus y1 squared. But let's say we forgot that. What did I tell you the distance formula actually was? No, that's the midpoint. That's all right. Try to get you on the right track later. What was that? The distance formula is nothing but the a squared plus b squared equals c squared. That is the Pythagorean theorem. That is correct. That's all it is. A squared plus b squared equals c squared. All right? So in this case, we are going to match, I'm thinking, AC and what? BD. Let's check that. All right? So AC is equal to the square root. Come on now, let's do the mental math. 4 minus negative 4 is what? 8 squared. Slow down, guys. Then 3 plus 2 squared.
25.
I'm trying to get you in here. Plus 25. So AC is the square root of what? Stop. Get a calculator.
89.
Don't even. Yeah.
89.
Yeah. All right. Now let's try to figure out what BD is. Square root.
$64, and then 25. That'd be 89.
There you go. So is it a rectangle? Yes, it is a rectangle because the diagonals are congruent. The diagonals are congruent. Anybody have any issues with that? Anybody have any issues? Yes.
Where'd you get the 64 and 25?
The fact that I did 4 minus negative 4. 4 minus negative 4 and 3 minus negative 2. There you go. Yes,
How
sir.
do you know to match AC and
I was hoping you would tell me that or ask me that. Listen, he is 100% correct. Or it doesn't have to be in that order. I just assumed it was in that order. All right, and if it didn't come out to be correct, I was going to draw it out. All right, but listen, does everybody understand what I'm saying? It doesn't have to be in that order. All right, but also there are times when you can like mentally plot the points and see how it has to be in that order. All right. So again, in my personal opinion, I should have drawn it out so you could see that they were definitely the diagonals. All right, but because it worked out, we were good. All right. Hopefully you were listening to that also. All right. You can't just assume the dots are in the right order. All right. You probably should mentally put them on a sheet of paper to make sure that they're not out of order, because on the test they're out of order. I'm just going to tell you. All right, they're out of order. You have to actually make sure it's in the right position. All right, so be careful with that. All right, I believe everything else is pretty easy. All right, so slope formula, distance formula, and so on and so forth. All right. Yes, ma'am. I think I said it was next Wednesday. All right, it's next Wednesday. So I still have another unit tomorrow. Then I have actually a couple more units, I think. All right. Now, again, remember what I told you guys. I just want to make sure you're hearing me. There's not a lot of tests this 9 weeks. All right. And I've tried to tell you it's already November. All right. And again, we are, you understand what I'm saying. And then there's a big break in November. And then there's a week of review and a week of exams. So we don't really have a lot of time. All right. So I'm begging you not to mess up and that you should be doing the problems. I'm going to work something out with these problems you gave me over the weekend and match that up with the problems I gave you on Friday and kind of give you a grade for that. All right, that should have helped. Some of you missed 4 questions on the thing from Friday, though. All right, so that's kind of annoying. All right, you just thought you were right and didn't have to check your work, and so you made some mistakes. All right, that's a problem. All right, that's a problem. So get to work.